All right, so the second part we're going to look at for sine and cosine graphs are the two transformations that affect vertical. Okay, we're going to affect the y values today. So yesterday we did phase shift, that's left and right. This is vertical and amplitude shift. Question? Okay. So both of these are going to go up and down. Okay? Vertical and amplitude shift. What's nice about the up and down is the numbers in the y column are very simple. Those are all your ones and your zeros. So all we're going to have to do today is arithmetic with ones and zeros. Right? We don't have to worry about the x column. That's got all the complicated ones in it, like the pi over 2. None of that's going to change today. Just the y's. All right, so first thing is, well, that's something else. Okay, so first thing I want to mention, just what is the amplitude? What does that really mean? Well, it's like the height. It's the height of the wave. If you kind of put a line right in the center of the wave, it's the distance from that center line to the peak. Or you could say the distance from the center line to the lowest point. It should be symmetrical. Now, since the amplitude is a height is a distance. Whenever you measure a distance, what kind of number do you always get? A length. So what kind of number is a length?
Always stupid. Positive.
It's always positive. So in other words, you will never have negative amplitude. Never. Okay? Amplitude is always a positive number. And I think I write that down in a second. So yesterday when we had a phase shift, it used addition or subtraction inside the parentheses. That was the two things you had to check. Do you have addition or subtraction?
Question.
Bless you. And then where is it? It is in parentheses. Amplitude change is different. Amplitude change is when you have multiplication. And it's multiplying by a number out in front. That's an example of an amplitude change. 3 sine x. -2 cosine x. Now, in the second one, there's actually two things happening. The 2 is going to do something, and then the negative does something else. Okay? And there's another example, 1/2 sine x. So anytime you multiply by a number, and it's in front of the trig function, that's an amplitude change. So as we go through the transformations, basically what you have to look for is what operation did you do, where did you do it. Anytime you add or subtract, it's always a shift. Yesterday we learned it was left and right shifts. Okay? I'm going to show you what an up and down shift looks like. But shifting always involves adding or subtracting. When you multiply, that involves stretching. There's two ways we can stretch. We can stretch it up and down, which is going to change the height, or we can stretch left and right, which would change the width. Okay, we're not going to stretch left and right today. Right? But anytime you multiply, it stretches it or compresses it. Anytime you add or subtract, it shifts it, left, right, or up, down. Right. So anytime you want, if you wanted to take any of those equations and find the amplitude of them, you're going to have questions like that on the test. Okay? It's not going to be a graphing question. Okay? We'll do some graphs later. But what I might ask you is say, all right, look at equation 1. I might say, what is the amplitude? All you do is look at the number in front. And remember, amplitude is always positive, so take the absolute value of it. And we'll practice a couple. And I already said that. Okay, so you know what? Let's practice finding the amplitude of these. All right, so based on the formula, it says take the absolute value of A. What's A? A is right there. It's the number in front. Okay. So what would be the amplitude of the first equation? 3. So when we get to graphing it, let me show you what it looks like. Here's sine, here's 3 sine. So the one in blue, that's the original, and the one in red is going to be 3 sine. So you can see what's happening. Okay. And if you count and look at the height, 1, 2, the height is now up at 3. It's because you put a 3 in front. Okay. What about -2 cosine x? What would the amplitude of that one be? 2. The negative is doing something, but it doesn't have anything to do with the amplitude. What if I made the problem this? What would the amplitude be now? Still 2. Whether or not there's a negative there has no effect on the amplitude, but it does have an effect when you draw the picture. Okay, we'll see what it is. What about 1/2 sine x? What's the amplitude there? 1/2. So this last one's kind of the opposite of the first one. The first one stretched it out, made it taller. 1/2 sine x is going to compress it. It's going to make it shorter. So as far as kind of hearing what that would sound like, let's take a look. So stretching and compressing it up and down would look like this. That's a stretch. That's a compression. As you can, I'm dragging the volume slider. So it's going to have an effect on the volume. Okay. Gets softer. Gets louder. So now it's getting softer and louder because I am actually changing the volume. When you guys heard it get louder and softer when we did the phase shift, that is a different reason why it's getting louder and softer. It's like the sound waves are canceling each other out. But this, I actually did make it louder and softer. So that's about it. That's the only effect that it has on sound. Yep.
Are we going to know about the sound of anything? Like, is there going to be a question, like, what would this sound like? I'm confused.
No, I'm just showing you what it would kind of relate to. Yeah. The other transformation we're going to learn today is shifting up and down. There is no connection with sound for that one. So I told you only 3 out of 4 I could really play. The second one we do today I can't. But the last one we do tomorrow, that one's I think the most interesting one, and I can play that one. All right. So the idea is if you put a number in front, it all depends on whether it's bigger than 1 or is it like a fraction, like 1/2 or 1/3 or 1/4. If you put a number that's bigger than 1, like if the absolute value of it is bigger than 1, it will stretch. So if you put a 5 in front, it will stretch. If you put a -5 in front, it will still stretch. The negative will do something else, but it will still stretch. If you put a number that's like 1/2, that will compress it. If you put a number like 1/3, that would compress it even more. If you do -1/3, that'll still compress it. But the negative also does something else. Okay, and we're talking about compressing it along the y-axis. So it's stretching and compressing up and down. Okay, just like that. Compress, stretch. So any questions on what an amplitude change looks like in terms of if you're looking at an equation, how you tell it's an amplitude change? All right, so if I gave you, let's say this. Let's go plus I over 2. Which one of those is a phase shift?
The one with the second one.
Second one, that's a phase shift. Which one? Which one is an amplitude change? First one. What's the third one?
Also a phase shift?
No,
it's not in parentheses.
Let's study that one.
It's an
We're going to do that one
phase
next.
shift.
It's what?
It's an amplitude phase shift.
It
Both of them.
is a shift, but it's just a different kind of shift. If the phase shift is left and right, you can probably guess what the other one is. How about this last one? We don't know. It is multiplication. So that tells, what did I say? Anytime you multiply, is that a stretch or a shift? Stretch. So it is a kind of stretch. The third one is some type of shift, which we haven't studied yet, and the fourth one is some kind of stretch, which we haven't studied. All right, but we'll do those last two eventually. For now, if you can recognize these two, that's good because that's all we've done. All right, so amplitude change, phase shift. All right, so every time we want to make a graph, we got to go back to the original table and look at those 5 important coordinates. I call them the 5 key coordinates to make the graph. So, we're doing an amplitude change, up and down. That means which values are not affected at all.
The X.
The x's. The x's stay the same. So, in the original table that I gave you yesterday, copy down the x's. So for every single problem we do in class and in the homework, here's your x's. 0, pi over 2, pi, 3 pi over 2, 2 pi. Every single problem we do today. So, if the x's are going to stay the same, the y's are going to change. Okay, so we have to find the new y's. First step to find the new y's is you have to know what number was in front. Was it a 3? Was it a -2? Was it a 1/2? You have to know what a is. So that's step 1. Look at what the number is in front, and then multiply all the old y values by that number. Notice I did not write absolute value of that number. Just use whatever number is in front. If there's a negative number in the front, use the negative. If it's a positive number in the front, then use it as a positive. Because I told you when you're graphing, the negative has an effect. So we gotta use the negative when you're making the graph. Only time I don't care about the negative is if I say, what is the amplitude? Don't tell me that it's -2 units tall. That doesn't make sense. Okay, so any questions on step 2? Step 2, very easy arithmetic because the old y values are 1s and 0s, so and negative ones. So all you have to do is multiply by a 1, a -1, or a 0. Okay, so arithmetic, very easy. Okay, so let's graph 3 cosine x. Okay, so step 1, look at the equation and ask yourself, all right, what kind of transformation is it? We've only studied 2, phase shift and amplitude change. Devin, which transformation is this one and how come?
It's an amplitude because we're multiplying it by a number.
Okay, I agree it's an amplitude. I agree we're multiplying, but we're going to do something like this too. And that one's also multiplying.
Because the number is in front of the function.
Right. So the whole key is, did you multiply and is it right next to the letter? Or is it out in front? Okay. Same when we do addition or subtraction. Is it right next to the letter? Or are there no parentheses and it's outside? So is it inside or is it out in front? Okay. This is out in front and multiplying. So there's your amplitude. Okay, so Aaron, what column can we copy down because it stays the same?
Yes.
Yep, the x's. And Connor, can you tell me what my x's are? Sine and cosine, the x's are the same.
0, pi over 2, pi, 3 pi over 2, 2 pi.
Yep. Don't have to change any of those. Okay, I'm going to put a box. On the outside of the box, I'm going to put the old y values. And then inside the box, I'll put the final answer. Right, so Jasmine, what are my y values for cosine? And this time we got to make sure we look at the right table.
1, 0, -1, 0, 1.
Yep. So there's my old y values. And now the last step, Kyle, what am I going to do to each one of those?
Multiply by 3.
Yeah, we're going to take all the old y values, multiply by the number in front. And that's going to give me the new y values. So if we do that, we're going to get 3, 0, -3, 0, 3. And there's my table. Okay, any questions on that? So 5, just like yesterday, 5 points for the x's, 5 points for the y's. Okay, now let's make our graph. Labeling the x-axis today, very easy. Pi over 2, pi, 3 pi over 2, 2 pi for every single problem. It's never going to change. Now, what I usually do is the y-axis, I change depending on what I'm scaling by. So normally I would put a 1 and a -1. What I'm going to do is put a 3 and a -3. Because that's what I'm scaling. The highest I need to go is 3. The lowest I need to go is -3. Okay, and now I'll just graph the points. So we got 0, 3. We've got pi over 2, 0. Pi, we're at -3. What else? 3 pi over 2, we're back at 0. And then the last one, 2 pi, back up at 3. Okay, and then just connect it. Remember, it shouldn't look like a V. Just it's part of a wave. You're just sketching that section of it. So try to make it look curved.
I'm confused. So, like, what is... So, you know how yesterday you said that you don't want to mess up your labelings on your lines, so you don't...
Yeah, you got to be consistent.
Yeah, so how does that work for the x-axis if the y-axis is like each line is 3?
You can use a different scale on each axis. Like you could, like if you were in Algebra 1 or something, you could go by 2s on this axis if you wanted. And you could go by 5s on this axis. Just as long as you're consistent on each axis.
Oh, okay.
So on the x-axis here, if you wanted to think of it in degrees, that's 0, 90, 180, 270, 360. I'm going by 90s. On the y-axis, I'm going by 3s. And there's your graph. Okay, any questions on that? Now, if you're looking at that and you say, well, that looks kind of the same as yesterday, it does, because I changed these numbers, right? Like, if you wanted me to graph 8 cosine x, I would actually draw exactly the same picture and go like this. 8, -8. So, if you change your scale, the picture is always going to look the same, because you changed your scale. If I actually had to draw something 8 times bigger, that could be hard because I might not have a big enough piece of paper. Or if I had to graph like 50 cosine x, it's a lot easier to do 50 and -50 than to try to draw something 50 times bigger. Okay? So that's why all my cosine graphs are going to look the same. Any questions on that one? All right. Let's look at this one. Okay, what, yeah.
So whatever the y is what you multiply by, right?
Well, this number, we call this one A. That number in front, we call A. Yep.
And then the y's always stay the same, and then we multiply by a.
So the x's stay the same.
X's stay the same.
And you
the
multiply
y's
the
change.
old y values by A.
Oh, okay, yeah.
Yep. So that's an amplitude change. But can anyone tell me what's happening this time? When you put a 1/2 in front. It's really compressing it. Okay? If it used to be a height from -1 to 1, now it's going to be -1/2 to 1/2. It's going to be compressed. Okay, so x's stay the same. Ellie, what are my x values for sine?
So it's gonna be 0, 1, I'm gonna look for it.
So I think you're probably thinking of y. It sounds like you started to say the y values.
Oh yeah, that's what I was gonna say. 0, pi over 2, pi, 3 pi over 2, and 2 pi.
What was that second to last one?
3 pi over 2?
Yep. And 2 pi. So now we still need the y values. It's just I'm going to put those outside the box because those are the originals. Okay, so Allie, what are my original y values for sine?
0, 1, 0, 0, 0.
Yep. And now we're going to multiply all the old y values. Peter, what are we going to multiply them by? 1/2. Yep. 1/2, 1/2, 1/2, 1/2. Okay, so how about Madeline? When I multiply those out, what will I get from my new y values?
1/2, 0, -1/2, 0, and then 1/2. Wait, what?
No, you did it backwards.
What? Okay, alright, I don't answer this.
So look at, what's the first? The first one is 0 times 1/2. What's 0 times 1/2?
0.
0. I think maybe you were thinking of cosine, I'm not sure.
Okay, 0 and 0.
Yep, what about the second one?
And then 1/2
Yep, that one's 1/2.
and 0.
There we go, 0,
Then -1/2 and then 0.
and then 0. Yep. So there's my x's, there's my y's. Last thing I'm going to do is graph it. Okay, on your x-axis, just put down the x's you already see. You don't have to put 0 because I know the axis is 0. But you do have to put the other labels. If you leave the labels off, I'm going to assume that this is 1, 2, 3, 4, 5. I'm just going to assume you're going by ones, which you'll see tomorrow. Sometimes you can go by ones, but not for this problem, because you don't want to do that. You want to go by pi over 2, pi, 3 pi over 2, 2 pi. And Ben, what's the highest y value? And the lowest? Okay. So again, this graph is going to look just like every graph I've drawn all week because I changed my scale. Okay. That's just how I do it. Okay. Now let's graph our points. So 0, 1/2, 0, -1/2, 0. 0, 1/2, 0, right about there, and there. And there's your graph. Okay, and as somebody said earlier, this graph has been compressed. So in terms of a sound, this would be a quieter type of sound versus a louder sound. Bless you.
Thank you.
Questions on that one? Okay, so I told you that when you put a negative in front, it does do something. So we're going to see what the negative does. Does anyone have an idea of what the negative will do? Okay, it's like having, you could pretend like it's a -1. Yep, it's the same thing. So let's start with the amplitude. What's the amplitude of that graph? For the amplitude? Amplitude is still 1. So this isn't technically changing the amplitude. But that negative still does something.
Divide.
You still do it the same way. It doesn't change the steps involved.
We go vertically.
Vertically. Yeah?
Does it flip it?
Yes. It flips them. So when you put a negative in front, it's going to flip it. We're okay?
You said the same thing.
Okay.
That is good.
Yeah. So all it does is flip it over. Whatever was positive becomes negative. Whatever was negative becomes positive. But let's go through it. So x's stay the same. Now, the original y values would have been 1, 0, negative 1, 0, 1. Change the sign of all of them. Multiply them all by negative 1. Negative 1, 0, 1, 0, negative 1. So remember, cosine normally looks like something like that. Looks kind of like that V shape. This is going to be flipped over more like a hill instead of like a valley. That's what's going to happen. So we're at 0, negative 1, pi over 2. Let's see, we're at 0. Pi, we are at 1. 3 pi over 2. We're at 0. 2 pi, negative 1. Probably should have put the label a little bit lower, but that's okay. And there's your sketch. Now, how come I'm only having you sketch one cycle? What did I talked about that yesterday.
Because they just repeat it
Right.
themselves.
It just repeats. So if you wanted the next cycle, all you'd have to do is copy and paste it, line it up right there. There you go. There's the next cycle. Questions on that? So we looked at all the different cases you can have for an amplitude. Stretching, compressing, and then flipping. Okay, so last transformation we're going to look at is another shift. Still on the y-axis. Okay, we already did the phase shift. Phase shift was yesterday. It's when the graph moves left and right. What two operations could you have for a phase shift? You could either have this, or you could have this. Addition or subtraction. It's going to be the same thing here. You could either have addition or subtraction. So what's the difference? This is addition or subtraction. Phase shift was addition or subtraction. How can you tell the difference?
It's on the outside.
Right, it's on the outside of parentheses. And there's a couple different ways you can write it. That's a phase shift. I mean, that's a vertical shift. For it to be a phase shift, you would have to do this. Phase shift has to have the letter and the number together. That's what we did yesterday. Okay. That's a vertical shift. That's also a vertical shift. Some people say, well, could you just put in parentheses and make it a phase shift? Depends where you put them. If you put parentheses here, do you think that's a vertical shift or a phase shift? Still vertical, unless you put the letter and the number in parentheses. That's a phase shift. Okay? Why you'd really put parentheses there, most of the time you wouldn't, but if you do, that's a vertical shift. If you had a problem where they put parentheses like that, do you think that's vertical or phase shift? Still vertical. I don't see parentheses grouping together a letter and a number. I see parentheses around a number that really aren't even needed. Okay? How about if I did this? What would that second one be? Now that's a phase shift. Yeah. Okay. So Both shifts use addition and subtraction. The question is where? Is it inside parentheses with the letter, or is it outside parentheses and the letter and the number are not grouped? Questions on the difference? So what do you think the major difference is going to be between this one and this one? One of them is going to do what? The other one is going to do what? One goes, yep, one of them's going to shift down, and the other one's going to shift up. Any guess which one is which?
One that's -3 is going to shift down,
Okay.
and then the 2 is going to shift up.
Okay. Now remember yesterday when we did phase shift, it was kind of the opposite of what we thought.
So is it,
Well, I'm not saying, I'm just saying yesterday it was the opposite.
so I'm right now?
Let's see.
Oh my gosh, that's a good question.
So when we did a plus yesterday, plus actually shifted left. When we did a minus, it moved it right. All right, let's see what happens here. Let's graph sine of x, and then let's do sine of x plus 2. So there's the original, and now the one in red has a plus 2. So it did move it up. It moved everything up 2. So this is a transformation where you do exactly what you would expect. Plus is up, minus is down. The transformation we did before this, kind of the same way. If you multiply by a big number, the graph got bigger. If you multiplied by a small number, like a fraction, it got smaller. All right? So both transformations today do exactly what you would expect. You don't do the opposite. So vertical shift will move it up if you add a number, down if you subtract. So now on the test, you got to remember which one is which. Phase shift is the opposite. So on your reference sheet, just make sure you make a note about that. Okay. Also, vertical shift, I can't really play a sound for you. There is no connection that I know of with sound on this one. And if there is a connection with sound, this program is incapable of doing it. It can shift left and right. It can stretch left and right, which I haven't shown you yet. And it can stretch up and down, which I showed you. But it can't shift up and down. That's not an option.
Wouldn't it just be the same thing?
The same sound? I don't know. I've never really heard anything with sound ever explains this way. I've never seen that in relation to sound at all. Usually when you draw a wave, you always put a line right through the center of the wave. You don't have the wave shifted off it. Okay? But that's what we're practicing right now. We are practicing shifting it up or down. Okay? Just no connection with sound that I know of. I'll look it up after. Okay. So last thing we got to do is find those 5 coordinates again. Okay, we know where it is originally. What happens when we shift it? Vertical shift can move it which way? Up and down. So up and down is which axis? The y. So if we move it up and down, the y's are going to change, but not the x's. So when you shift up and down, keep the x's the same. Okay, and where are you going to get the x's from? The original table that we had yesterday. All right, now, how do we get the new y values? Well, first thing you have to know is, what did you add or subtract? Did you do a +2? Did you do a -3? Did you do a +7? Like, what did you add or subtract? You take the number that you added or subtracted, and you add or subtract that number to all the original y values. So if you had a +2, you would take in +2. If you had a -6, you would -6. Don't do the opposite. Don't do the opposite. People will. I'm telling you. I think they'll do it. Don't do the opposite. I don't know any other way to say it.
Do what it says.
Do what I wrote. Don't do the opposite.
Do whatever.
All right. Any question on that? I'll do the opposite. All right, so let's graph y equals sine of x plus 2. All right, now we know 3 out of 4 of the transformations. I'm going to go back to that page where we had a couple question marks. Right here. So I asked you which one was which. You guys told me the first one was an amplitude, the second one was a phase shift.
The third one's a vertical shift.
The third one, now we know, is vertical shift. Fourth one, we haven't done that one yet.
Oh, you didn't have this.
What's that?
The other one you have today.
No.
You can't hit it. I can't.
So now we know when you add or subtract at the end, vertical shift. Okay, let's go back to our problem. Sine of x plus 2. All right. Vertical shift. What column stays the same? X's. What are my X's? For everything we've done today.
0.
0.
Pi over 2. Pi. 3 pi over 2. And 2 pi.
Okay, so we got our X's, 5 points for that. We get the Y's, 5 more points. Now, when you get quick at it, sometimes you might not need the originals. You can just do the plus 2 in your head. Let's just write the originals this time, just so people can see the calculation. Jose, what are my original Y values for sine?
0, 1, 0, 0.
Yep. And now, I have a plus 2. So what am I going to do to all of those?
Yeah. I'm just kidding.
Don't do the opposite. Did I? So we're going to plus. And what are we going to plus?
2.
Plus 2. 2, 2, 2, 2, 2. So this arithmetic, I think it's even easier than multiplying. All you have to do is add 2. So what are going to be my Y values?
2, 3, 2, 1, 2.
Yep. 2, 3, 2, 1, 2.
You did it, that's why.
Okay, questions on that? Okay, so now the last step is to make your graph. On the y-axis, you got to leave a little bit of space because we do have to go up to 3. Okay, so that's, I would make sure you have enough room to at least put 3 marks. 1, 2, 3. X-axis, you're going to need 5, just like always. 0, pi over 2, pi, 3 pi over 2, 2 pi. If you don't put 0, that's fine because I know the axis is 0, but if you want to put it, you can. Also, I put my labels down below because I know this graph is shifting up. So I'm not going to be drawing anywhere down where my labels are. I'm going to be drawing up in quadrant 1. Okay, now let's put our points. So we got 0, 2. Pi over 2, we're at 3. Pi, we're back to 2. 3 pi over 2, that's where we hit the lowest value. And 2 pi, back at 2. So there's your sketch. It's your sine function shifted up 2. Now, if I asked you on the test what the amplitude is of that,
I forgot what that was.
2.
what's the amplitude?
2. 1.
2.
1?
It's definitely 1
Why 1?
because
It's 2.
I don't
Wouldn't it
know.
be 2?
There's nothing in front of the sign, so.
There's nothing in front of the sign,
Is
so
that
if
where
you,
it usually goes?
if you wanted to put something there because there's nothing, you could pretend like it's a 1. Also, think back to the picture. The amplitude is the distance from the center to the highest point. So let's look at our picture. I didn't put the line in, but imagine there's a line right there. The distance from the center to the highest point is 1. The amplitude there is 1.
Is tomorrow easy? Or not tomorrow, but Thursdays.
It's kind of like yesterday's.
Oh,
Oh, wait. The amplitude is like the lowest point.
no,
The amplitude is the distance from
middle point.
the center up to here. That's the amplitude.
Oh, okay.
This is also the amplitude. That's also a distance of 1.
Okay.
Question, yes.
Have you decided if we're having a test on Friday or not?
We're having, yes.
We are?
We are having a test on Friday.
Yep.
Yep.
Awesome.
Okay. Any question on that one? Okay, just tell me what would happen in this one. What kind of transformation is it?
It's a vertical.
Why not a phase shift?
It's not the letter and the number are different.
Right, the letter and the number are not in parentheses, so I agree, it's a phase shift. Which way is this going to move the graph?
Down.
Down, how many? 5, yes. It's going to take cosine and move it down 5. Right?
Wow. This.
I just wanted to kind of go through what would happen. Any questions on that one?
No.
I think, again, these are probably the easiest type.
These two are super easy. Can we have a test on these last two?
You will see those two on the test.
Oh, just this.
Not just those two, no. I have to give you the other stuff too, it's a rule. It actually says it in a book, I have to give you the other stuff.
Right?
Wait a minute, I'm confused.
I just didn't remember.
Okay, so homework tonight, it's another worksheet. Okay, so you don't need your book. 5 problems. I'm going to give you the next 15 to 20 minutes to start it. So if you finish it, just show me and I'll check it off. But please use the time to try to get something done. Okay?